In this exercise, we have to calculate the yearly level premium on a discrete endowment insurance of 2 years for a life aged 55. So for that, we're going to use the equivalence principle and recall that this states that the expected present value of the premiums must equal the expected present value of the benefits. Now, let's start with the former because it's slightly easier. We assume that the premiums are paid throughout the term, and in this case, the term is 2 years, as stated here. Therefore, we get, so EPV of the premiums is going to be P for the premium that we have to calculate, which we have to multiply by payments of 2 years for life age 55. So it's going to be at the start of the year. So we have the small a double dot, life age 55 for a term of 2 years. And this is the expected present value of this. Now, we can use the definition, and this is equal to 1 plus surviving for 1 year. But then we have to discount, so we have to discount by V. And this is it. It's only 2 terms. And we can calculate this using the information that is given, because Q55 is equal to 0.1. Therefore, V is 0.95, but therefore P55 is going to be equal to 0.9, of course. And this gives us 1,855 times P. So this is the EPV of the premium. Now for the benefits, it's going to be, you have to watch out because there's a little extra given in this case. So because the death benefit, it states it's going to be 10,000 euro plus the refund of all premiums, as is stated here. Now, it says we do not get the interest back. So we do have to discount, but we do not receive the interest. And there is also the part of the pure endowment of 20,000. Now, if we draw this in a quick timeline, let's see what happens. So if this is t is 0, this is t is 1, this is t is 2, then from the point of view of the insurance company, they receive a premium here, and they receive a premium at t is 1, and they will have to pay a death benefit here. So let's say death benefit, and maybe here at the end of the year. And if the person survives, then it will be so it's going to be also here, but just after survival. So that's going to be the pure endowment, let's say. So the red ones are conditional on dying here or here, and the blue one is if the person survives for these 2 years. All right, now let's write down the formulas of this, the EPV of the death benefit. It's going to be 10,000 times the EPV of this term. So it's going to, the death benefit is for life aged 55, paid at the end of the year for a term of 2 years. Similarly, for the pure endowment, the life age 55 has to survive 2 years, and then we have to properly discount. So that's the 2E55. Now for the premiums, we're going to have to be careful about the refund because it depends on how many premiums you have paid. Because if we are to be in this case, then we will only have paid 1 premium. And so what would the refund be? Well, it will be the premium refunded, but only once. And it will be paid out at the end of the first year. So that's going to be So if we die in the first year, life age 55 dies within a year, then we get paid the premium at the end of the year. So we have to discount properly. Now, if we survive for at least up to here in this year, so we survive for at least a year, then we will have paid 2 premiums. So we get twice the discounted value back. And what is the discounted value? It's going to be v squared. We have to survive 1 year, and then we have to die in the subsequent year. And that's it. So these are the benefit expected present values. Now by equating these two, let's actually write this out, and then we can equate the two equations. So this is equal to v times q55 plus v squared, and then survive for 1 year and die in the subsequent year, plus 20,000 times, so discount for 2 years, and multiply by the survive probability. So we have to survive for 1 year from 55, and again for 56. And this one does not change, so the premium we state the same way. Plus v squared p55 q56. Now plugging in all the values from here and noting that p is of course 1 minus q, then we obtain that this is equal to 10,000 times 0.19247. I get a comma to be clear, and this is 20,000 times 0.71478, and this is equal to p times 0.2899. All right, and then solving for p, so we equate the two equations using this equivalence principle, which gives us that p is equal to 10,364 euros, which is the yearly level premium, and solves the exercise.